We often write functions as y equals f of x because each x value determines exactly one y value. And many times we use formulas to determine what the y value is. Such as for the function y equals x squared, given an x value, such as x equals 3, we can find the y value by computing y equals 3 squared, which is 9. But what if it's the other way around? What if we know the y value and want to compute the x value? In other words, we want to know which x value gives us a certain y value. Well, we have done this before many times, typically when finding the x-intercept. There, we wanted to find the x values that gives y equals 0. This is the idea of an inverse. For a function y equals f of x, which takes an input value of x and gives an output value of y, an inverse of f works the other way, taking an input value of y and gives an output value of x so that y equals f of x. So an inverse has an input and an output. But is it a function? Remember, a function has exactly one output for each input. So what happens if two input values x of f of x give the same output value y? For example, if y equals x squared, then f of 1 is 1 squared, which is 1, and f of negative 1, which is negative 1 squared, is 1 as well. So two x values, 1 and negative 1, give the same y value of 1. But for the inverse to be a function, it can only send each y back to 1x. So does the inverse send the y value, y equals 1, back to x equals 1, or x equals negative 1? Since a function can't give both outputs of 1 and negative 1 for the one input of 1, this inverse is not a function. Now, we just had trouble defining an inverse for the function y equals x squared. The trouble came from having a y value paired with two x values. And anytime we have a y value paired with two x values, we will have the same trouble finding an inverse. But as long as each y value is paired with one x value, then we won't have this trouble finding an inverse. But we studied functions where each y value is paired with one x value. These types of functions where each y value is paired with one x value are called one-to-one. So we can conclude that if a function y equals f of x is one-to-one, then it has an inverse function. And we write the inverse function as x equals f inverse of y. And f inverse finds which input of f gives a particular output of f. As one final note, because it is customary to call the input of a function x, we will often make x the input of f inverse, and write it as y equals f inverse of x. But still, f inverse finds which input of f gives a particular output of f. We've just switched what we call x and y.